right. Perfect. And I reckon we just wait a few minutes, get people to come in. Perfect. Yeah, and let me know if there's any good questions on there that I can also answer. All right. Yeah, should I start now or just wait a couple minutes? Perfect. Perfect. Okay, so assignment 2. Welcome to the assignment 2 live stream. We're just going to be going through a few details of just an overview of the assignment and how you might want to get started. So assignment 2 is going to be on linked lists. You would have just started linked lists in week 7 in those lectures if you've watched those. And I hope that you've enjoyed those because you're going to be looking at linked lists for a while with this assignment and for the rest of the term as well in general. Okay, so this term we've made the assignments 1511 climb. Thought it was appropriate since all of the 1511 staff have now started going climbing. Many of the 1511 staff have been climbing quite regularly. And we've basically made it into a little logbook. So you've got climbing routes that you can attempt. I'll quickly bring up there we go. There's a quick little diagram of it there. Oh, that's not quite what we want. There we go. So to start off with, we're just going to have a logbook. And then we're going to have some climbing routes. So each of them will have some details, a name, difficulty, length, and all of that, things that are associated with a climbing route. And then they're going to be linked together in a little list, because it is, of course, a linked list. All right. And if anyone wanted to look at kind of the inspiration for this, you can look on here. Basically, it's a climbing it's a website that stores climbing routes. That is about it. You can see routes has ratings, has difficulties, has lengths and all that. So that is the inspiration if you wanted to have a little explore. All right, so to get started, let's have a quick look at getting started. So as we saw earlier in the diagram, we've got a struct logbook, and that's like a little book where you can, like a logbook, you can log how many climbs you've done, things like that. You can log climbs, climbing routes that have been set up by people. And we have struct routes. So these will store the name of a route, difficulty, length, and all of that. I'll go into that in a second. All right. So we'll start with how you actually get started with the assignment. You'll want to get started by just going into VLab or VS Code or wherever you are coding from. And let's see. Yeah, there we go. So if you are on a CSC machine, you can run this line of code to get the starter code. So that should look like something like this. All right, so if I just copy that in, that should show us. If we ls again, you can see that we have the file here, and that is csclimb. That is where we are going to be running all of our, that's going to be where we're writing all of our code. So if I open that up, right, open, yep. Oh, Tammy, the light mode is hurting my eyes.
I'm so sorry.
All right, so this is, you'll notice it's going to seem a little bit overwhelming at first. There was a lot more starter code in assignment 2 than assignment 1. So to start off with, we've got, I'll just give a quick overview. We've kind of got hash defines, enums, and structs, and then we've got function prototypes and all of that. And then down here, we've got the main function. So this is, of course, where you'll be, this is where you'll kind of start off with writing code, maybe a command loop, and then like calling functions and things. And then there'll be the actual functions that you want to implement. And then there's some provided ones. I'm just going to grab a bit of water, and then we'll keep going. All right. So there's a few provided functions, quite a few, that are potentially a little confusing. So the ones that you will need to use, if I scroll up, are these ones over here. So the extra ones as well you can take a look at, but you don't need to know how they work at all. Okay, I'll go through things a little one by one. So let's start with the enums and structs. Enum attempt type, don't worry about this until stage 3. I'm going to ignore it here. Struct roots and struct logbooks. We've got these here, and these are what you're going to be dealing with for the whole assignments. So from stage 1 onwards. All right, so the struct root represents a single climbing route. So it has a name that whoever set it up gave it. It has a difficulty. The difficulty we have in the assumptions of the spec. It'll give you the maximum and minimum difficulties, same as the maximum and minimum lengths, which could have been put on here, but I forgot. So we've got a name, a difficulty, and a length. And then because this is a linked list, we've got a next pointer that points to the next struct root in your list. And that's what's going to make this a linked list, and hence you'll be using a lot of linked list techniques in this assignment. All right, then we have a struct logbook, and that is just going to contain at the moment a pointer to the start of our list of roots. So that's essentially going to point at the head of the list that contains all of these struct roots over here. All right. And you can edit these if you want. You don't really need to edit them at all, aside from in stage 3, where we will give you kind of specific instructions on what you might want to change about them. All right. So the provided functions in here, these are the ones here that you will be using. And then these ones here, again, you don't need to look at them. We just use them. We call them within some of these functions to make them work fine. All right, so in terms of those provided functions, we've got one for printing usage. This will be in stage 1.2, which will be for setting up the command loop. It's just printing out a message. It just prints out all of the commands, and so you don't need to look at that too much. And then there's other functions for printing out other information and scanning and things. Again, the spec will tell you how to use all of these, and some of these comments will also show you what the usage looks like. All right, yeah, and these ones you don't need to worry about at all. So anything below here, don't worry too much. You can look if you are curious, though. Okay, and the last thing to go over here with the starter code is that these ones here, your functions, these are the functions you will need to implement. So the logbook function is already implemented for you, but the create root function is not. That is going to be stage 1.1. And that is going to be just mallocing a single root and then initializing all of its fields to sensible values, and then from there just returning that for use later. Anything else with starter code, Tammy? Nothing much? Cool. All right, so let's take a quick look through here. Okay. So that's the starter code briefly. Just went on a little sidebar on that. So next with getting started, one thing you can do to check that you've gotten the actual code downloaded right is just run the auto test. So if we run that over here, that's still in there, perfect. You'll see it will compile it and oh yes, that is actually the note that I wanted to make. Yeah, that was one I mentioned to Rory before. Cool. So one thing that I have included in here, which did need to be adjusted, is the logbook here. So let me see if it shows actually. Sorry, going on a slight tangent to see if it shows us what happened here. Yeah, so one thing that has been included in the starter code, which I mistakenly did not fully deal with, is that this line here causes a warning, which gets treated as an error later. So just because this doesn't get used until stage 1.3, so if you want your code to compile correctly to start off with, easiest thing to do might be to just comment that out. So actually, let me just correct that. Yes, we might update that, because that would be helpful. All right, so once you've done that, or once we update the starter code correctly, then everything should run, but everything should also fail, because of course you haven't implemented anything into your assignment yet, as you can see. And we don't need to wait for that to all go. So I'll just skip the rest of that. All right, so once you've done that, should have a read through stage 1, and then, yeah, try and kind of plan through a bit of a solution before you get started. A bit of forward planning can save a lot of time later down the line, so you don't have to redo everything. I'm sure a lot of you learned that in assignment 1, when you put everything into the main function and then realized later that functions were actually very helpful and tried to move everything and had a hard time. Forward planning will be helpful to avoid things like that. Okay, cool. So we'll go over this. So as this hint says, you don't have to deal with any kind of invalid commands in the sense of like a command that doesn't actually exist, or someone giving too many arguments for a command, or someone giving like a really long command. You don't have to worry about any of that over here. Okay, reference implementation. So we've provided a reference implementation, which just is the completed code, and that is going to essentially have the correct outputs for anything that you type in. So this can be good to check. First of all, just to get an idea of how it works, you can just have a play around. Let me see if that's going to work fine. So you can have a play around with it. And also, if you see something and you're not too sure how it should work, or you're not too sure how a specific input should be handled, you can also double check anything specific here. So what we might start off with here is, just expand that a bit, using the question mark, which is going to bring up the help kind of command. And this will be helpful as well if you wanted to just look through and see what all of the commands actually are. So it's just split up into each command in the order that you will implement them in. All right, and then we can press Control-D to exit that. All right, starter code. We've gone through the starter code briefly already. Commands, there's also a list of commands. I've attempted to match them up vaguely with what they do, hence the bold letters, but you can just look up here to see what the commands are, or you can also pull up the help screen if you kind of forget a lot of them. All right, importantly, this is a linked list assignment, so arrays are banned. The only exception to that is char arrays, so strings, since we're using those to store names and details like that. Otherwise, any other content that we've covered is fair game. You can use all of it. If there's content that we haven't covered, you can use it as long as the style guide doesn't explicitly ban it, but you might not be able to get help from tutors if you use something that isn't taught in 1511. And of course, yeah, if you do use things that are not taught, you still have to follow the style guide. So we've linked to the style guide here, and you can read through if you're unsure about anything. All right. Okay, so we start off with stage 1, and stage 1 of the assignment is essentially just going to build up to making a linked list that looks something like this. So first of all, stage 1.1. So 1.1, all we're doing is implementing the create root function. This is already in the starter code. So if we have a look, that is the first one here. So what we're going to want to be filling in here is the actual mallocing of memory for a root, and then you'll be initializing all of the values to whatever values are passed into the function, or the fields of the struct root, I should say, and then you should return that. And also, it would be very helpful to fill in the function comments as well, so that you know what the function does, and anyone else reading your code later on knows what your function does. Hint, that might be your tutor who is marking your assignment for style. So those are going to be helpful. Okay. So I should also mention the format of the assignment spec. So each command is going to have, or each kind of stage of the assignment is going to have some like heading and a lot of little sections for you to read through. For each stage, you should absolutely read through everything for it. So for stage 1.1, you should read through all of these, through the assumptions, testing, all of that. And this might be sometimes a little bit overwhelming because sometimes there's a lot of things to look through. But if you read through everything just like section by section, it'll give you a greater understanding, and also you won't miss little details because sometimes there are details or assumptions that we put in there for you, and if you don't read them entirely, you might miss something important and then have to redo all of your code later. So make sure you read through everything first. Okay, so yeah, we went through this. Cool. And we've got a few hints for you throughout. So for example here, with strings, you can't just set one to be equal to another. You have to use a function for that, which we've looked through already. Okay, so for 1.1, we can't really auto test your code very well because there's no outputs for it. So what you can do instead is you can copy this kind of testing code into your program, and from here you can test whether it's actually outputting things correctly. So for example, if our create root function was working correctly, we could run this and expect this output. But since we don't have that running, if I test this, it should fail in some way. So this is how you might use this testing code. Once you've set up your create root function, you might just copy that testing code, literally just somewhere in here. Something like that. And this is calling the create root function, and we're passing in the arguments for it, which is the name, the difficulty, and the length of a struct root. And then it should print out everything correctly. However, if we try this, let's see. right. Then if we run this with our testing code, it should, at the moment, give errors because we've returned a null pointer and you can't access the fields of that. But if your code is working correctly, it should give an output that looks something like this. So it should print out the name, difficulty, length, and it should show that the next field is null. All right. Importantly, once you're done, as this warning states as well, make sure you delete this code. Otherwise, all of the auto tests will fail because they see extra output when there should not be any. All right. So stage 1.2 is operating, starting off the command loop. So the command loop is essentially the controlling the loop in which you give commands. And this is going to be a very similar kind of setup to assignment 1. And as you can see, we've actually linked to that over here as well. So you can have a reminder of how that's going to work. I think it's stage 2.1. But you can look through that yourself. All right. So the basic kind of like flow of the program once you get it running, so once you have this command loop running in stage 1.2, is that it's going to print out the welcome message. It's going to run a loop, and each time it's going to prompt you to enter a command, scan a character, and then scan any arguments, and then just keep looping after it runs that command. So we can demonstrate that just quickly with the reference spec. So again, that's just 1511 and then cs_climb. And we can see if we enter a command like that, it shows all of the help info and then shows enter command again. And if I use another command, which we'll look at in a sec, it will just keep prompting for commands until we press Control-D. So I'm going to do that now, Control and D. And it'll print out goodbye and then end our program. OK. So another way you can find program that has a similar structure is CS Calculator. And that is in the week 4 labs. And I think as well, are the solutions for week 4 out? Week 4 labs? Yes. They might be out. So there we go, CS Calculator. It's going to be a very similar kind of structure to this as well. So it's similar to this, and it's similar to assignment 1. So if you get stuck, you can look at these kind of programs for a bit of a help. Stage, yep, week 4 lab solutions are out. Yep, so even if you got stuck on the CS Calculator, you could look at that for some advice. And that's probably about as big of a hint I can give for that. All right, so that is the command loop there. And then along with the command loop, you've got one command that we're getting you to implement. And it's very basic. You just input a question mark as the command, and then it prints out all of the commands. So that's what we've shown so far through here. You can see the question mark command here. One thing to note is that we've provided a hash define for that. So that is over here. And we'd recommend that you use the hash defines that we provide and also include your own hash defines, or write your own hash defines as you go through. So for things like command characters and for anything like maximum values for fields or minimum values, for example. All right. What else have we got here? Yeah, so other thing with the help command is that the only thing you have to do is really scan in the help character, so the question mark, and then you just have to call this function. So it's quite simple at this stage. You just have to call print usage, and that is going to do all of this work for you. Don't try putting all of this in manually, because if you try putting all of this in manually, it's going to be a pain. Make sure you use the helper functions where they are provided. And in the spec, we will always give you any helper functions that are relevant. So for example here, we've got the description of the command, and then we've got the helper function that is relevant. So you can also just click on that. It will take you down to the helper functions, and it will just tell you quickly how to use them. All right. So 1.2, this goes through the kind of enter command like loop and ending it at Control D, so what we've covered just earlier. And again, make sure you read through the entire spec for each stage, because there are some assumptions here, for example, that are going to be quite helpful. So for example, for this stage, there's no error checking. That's going to be in stage 1.5. And you're always going to have the correct number of arguments for every single command you have. And a couple other ones here. So always make sure you read through these. Then along with these, each spec for each stage is also going to include some examples. So for example here, it shows that if you input the question mark, it should output all of this. And then when you press Control D, it should do this. And same thing if you print it multiple times. So this is another way that you can check your code. You can manually put in each command and see if the output matches the examples here exactly. Or you can even check against the reference spec, reference implementation. All right. One other helpful tip is to, let's have a look at this one instead. One other helpful tip, just take note of the Control D again. It's a common error to get to the end of the your program and then just like exit some other way. And so make sure you use the Control D to exit, because that's how the auto tests are going to do it. Otherwise, you can run into errors. All right. So the next stage. Yes, one other thing to note here is that once you get the auto tests going, you always have a note at the end of each substage that tells you how to auto test that specific substage. And you can see they only test a specific stage, so this way you don't have to run through all of the auto tests every single time. So for example, over here, I could run this, and that will fail because I haven't implemented it yet. Oh. One of them will pass, because that is making sure your program runs correctly when there are no commands, but everything else should fail there. All right, so that's how you will auto test your things. And again, all of these you can type in manually, but sometimes it's just quite easy to make errors, so like there's no reason not to copy and paste these in as well. Okay, appending roots. So now that you've got the command loop going, we're going to start implementing commands. So the first one is we're going to essentially build a little logbook that contains a list of climbing routes. And that's what the append route function does. It takes your list of routes and it appends a new route onto the end of it. So if you will start out with a logbook that is empty. So it will have a routes pointer that points at null, and then after you add one route, it will look something like this. After you add another route, that route will be attached onto the end of the list and look like this. And so this is how you're going to build your linked list of struct routes. Okay. So we can have a quick look at what that looks like if you run the reference implementation, but I might actually wait until we look at the printing first. Actually, no, let's take a look. So for stage 1.3, if I run the reference implementation here, we're basically just adding the ability to add roots to our logbook. So that would look like R for root, and then some kind of name, so eternity, some difficulty, 18, some length, 22 meters. And it's just going to say root eternity added successfully. And that's kind of all we test with the auto tests. So one big thing to note here is that when you run the auto test for this, all they're checking for is that you pretty much have this output being given there correctly. So we haven't actually started printing anything out yet. So even if you pass the auto test for this stage, you might not actually have a working implementation yet because we haven't actually printed out to check whether you've added everything in the correct order and added everything onto the list. So that's one thing to note. If you're failing stage 1.4 auto tests, it might not be a problem with stage 1.4. It could actually be a problem with 1.3. All right, and again, let's just take a quick look through the spec. So we've got the description of how this works, the arguments, and we have a helper function for you to scan in a string. That's going to be used to scan in the name of the root, because that will be a string. And again, you can click on this to go to the actual, that's something that needs to be fixed. You can click on that when it's fixed, and it will take you to the provided helper functions and a quick description of those. Okay. Again, there are assumptions here. So some similar assumptions to stage 1.2. And again, error handling is not going to be something you have to deal with at the moment. So you can assume that every command for now is going to be valid. And that is what I mentioned about the auto tests in stage 1.4, and that is the auto test command. Tammy, anything I've missed in general here, or not too bad so far? Cool. All right. So so after stage 1.3, which is adding roots, a very important stage is printing roots. So to print the roots, it's going to be the command P, and that's just going to print out all the roots in your logbook. And this is going to be very helpful as well to check whether you've added roots correctly, and for us to check with the auto tests whether you've added them correctly as well. So it takes no arguments. It just prints out all the roots in order. And we've provided a helper function to help with the printing, so you don't actually have to worry about all of the formatting. You can just print them out by using that function. And that is in the starter code, of course. All right, so we can see what that looks like. If I run the reference implementation, which I've done and have the root already added, eternity, then I can use P, and that's going to print out the info about that root. And if I was to add another root, so for example, Pharaoh, which is 15, difficulty of 15 and 18 meters long, then we can take a look and see that we have root 1, which is eternity, followed by root 2, which is Pharaoh, because Pharaoh was added to the end of that list. Okay, no errors or assumptions there. Again, there are examples, so you should be able to follow each example and be able to see exactly what the output should be like. So if you run this yourself and run it manually, which we highly recommend, then you should be able to find this output. That's another thing to note. Auto tests are very helpful, but auto tests give you a lot less control over actually testing it yourself. So especially if you're debugging as well, you'll want to put in commands and things yourself rather than just running the auto tests, because they'll tell you if your code is correct or not, but often running it yourself will show you like where your code might be going wrong. So that's something helpful to note there. All right, now quite an important one is 1.5, where we're going to be handling errors. And from here on out, from like stage 2 onwards as well, each substage, each command is going to come, most commands are going to come with some kind of error conditions that you have to handle. So for example, in this case, we are, if we tried to add a route that has a difficulty that is much too high or a length that is not existent or too long, then we should throw some errors. All right, so real quick as well, I'm just going to jump back to the top, just because, yeah. So what I didn't cover in the starter code was the actual limits of each value here. So this is where the description at the top is helpful. For a struct root, there's some limits on the actual fields, on the values of the difficulty and length fields. The difficulty will always be between grade 0 and 39, and the length will always be between 1 and 60, because you can't really have a 0-meter route, and having a route over 60 meters becomes very long and difficult to manage. So that's why there are those limits there. Okay, so if we go back down to stage 1.5, all right. So 1.5, yeah. Error handling is going to be quite important. So for this specific stage, 1.5, you're going to be checking only the append root function, essentially. So all of the arguments that come with the append root function, you just need to make sure that they are within the correct ranges. So stage 1.2, that should be corrected. That's, you have to modify the code you wrote in stage 1.3, appending roots. I'm going to fix the small typos we've got here after the live stream. So for every command after this as well, you're going to be looking at a few errors or potentially a few errors. And for all of them, you're going to want to check them in a specific order. So each time you run a command, you still want to scan in every single argument. So if it's the R command to append a root, for example, you're still going to want to scan in the name, the difficulty, and the length. But you want to, after you scan those in, you want to double check each of them. So this would probably involve at the start of your append root command, or start of the append root function if you write one. You'll want to have maybe some if statements saying if the difficulty is not valid or the length is not valid in some way, then you should print out these messages and not add the root. And yes, as mentioned before as well, you should do this in a certain order. If the difficulty is invalid but the length is also invalid, then you should only print out the difficulty invalid error, and this one you can ignore. So always doing it in this order from top to bottom. All right. Scanf or fgets. So for this assignment, scanf is going to be the most helpful for scanning in each argument because you can just do it one by one. Fgets will scan in the entire line at once, whereas scanf you can say I want to scan in a string and then an integer and then an integer, for example, and that will be more manageable. Speaking of actually though, when you're scanning in strings, you'll want to use the scan string helper function. So that is mentioned in stage 1.3. That is over here. And that's what you'll want to use to scan in strings. For scanning in characters, for scanning in integers, you'll just be using regular %C, %D, as you would have been doing so far. All right. Other than that, again, we've got examples for each one. And that will be about that. Cool. And again, yeah, little hints and things throughout. So again, there are often a lot of little boxes and a lot of like clarifications and dot points for every single stage. Make sure you read through all of them before you start on that stage, because otherwise you might miss something important. Or you might also miss some hints. Sometimes you'll be working on something for half an hour and then realize that the hint actually just gave you the solution already. So that can be quite helpful. All right, so once you get to the end of a stage, you can test the entire stage with the auto test commands. You can run 1511 style, which you can also, again, you can also do this during like any time you're writing your assignment, or like at any point throughout it. And it's going to be helpful because style is not just for like marks, although obviously we are marking it. Style is for you when you're writing your code and for your tutor when they're marking your code, so that it is more manageable, it's easier to debug, it's easier to understand what's going on. And so 1511 style is a good tool for checking that. And give. So give you can run after each. So we recommend you run it like after each stage, because you might break things as you keep going, and it's good to have it submitted and also have essentially a backup there, because that will store it on the CSE system under your submissions page. So you can access it there. And I can show you what that looks like if that is set up, which we'll find out. So if I use Control D to exit, to end that program, I should be able to run this. And then same thing as with labs and assignment 1. It will test everything, and for me, of course, it's going to fail all of them, but that is how you should submit. And you can submit, yeah, as many times as you want, so you don't have to submit just at the end of, just going to, well, just exit that so the auto test didn't all run. You can submit as many times as you want, and only the last submission will be taken, same as assignment 1 and all of the labs. So there's nothing you can lose by submitting more times than you need. So you might as well submit as you go along. Okay. I'll quickly go through stage 2 as well, and then briefly stage 3 and probably not stage 4. Okay, so stage 2 is where we start just running a few other linked list, a few more complicated linked list functions. So for stage 2.1, you're basically just going to go through and only print out the routes that have a specific difficulty within a certain range. So instead of printing out all of them, like you would with the P command, you'll only print out a few of them, whichever ones come within the range you give. For example, you can see to run this command, you do F, and then you pass the minimum and the maximum difficulty that you want to show up. And then if you were to add all of these routes, you can see they all get printed out when you press P, but when you press F, when you put in the filter command, it only shows you the routes between these two grades, so only, in this case, Eternity and Psychopath as the climbing routes between difficulty 17 and difficulty 20. All right, same as before, you've got provided helper functions to help you print routes, you've got errors to check, and there's some assumptions.
Recompiling and retesting the program, is there some fast way of typing in a long list of instructions without having that you might have typed in?
Ooh. So yes, there is a way of doing that. So you can have an input file, and then you can use that to run. You can use that and essentially pipe that straight into the assignment program. I might leave that for someone on the forums or something to answer. So I reckon that's probably the best solution here, just so I cover only the basics here. So you can post that on the forum, and someone will be able to show you like the exact way to do that. So how to pipe something from an input file into the assignment. Yep. All right, so next in stage 2, we've got inserting a root. This is just going to be very similar to appending a root, except instead of putting it at the very end of the logbook, you're going to put it before a root that already exists. So in this case, if you were to have some list that looked like this, so we've got the roots eternity, Carthaginian, and psychopath. And if we were to put in the roots Joseph just before Carthaginian, that would look like this. So essentially, we kind of we kind of keep everything else in the same order, but Joseph just gets inserted after eternity before Carthaginian. And this is going to be quite similar to appending a roots, except for the fact that once we create the root, we're going to be inserting it instead of just adding it to the end. Again, similar errors here, and you want to check these in this order. Okay, stage 2.3. This is just going to be changing the length of a bunch of roots. So if you pass it the names of 2 roots in your linked list, then it's going to apply whatever length change you pass in here. So if you're going to add 5 meters to all the roots between, let's see, if you want to add 5 meters to all the roots between eternity and psychopath, that will change the lengths of all the roots from eternity, pharaoh, Carthaginian to psychopath, and that will show up next time you print them. There are a couple caveats, of course, though. Yep, the roots might appear in any order, and if any of the roots would become a root that has an invalid length, then you should change none of the root lengths. All right, so that's stage 2.3 briefly. Stage 2.4 is just swapping 2 roots. This is fairly self-explanatory, but a little bit more complicated than it might seem at first. So there's a lot of edge cases that you're going to have to consider here with swapping 2 roots. And so you'll have to go through them one by one. So we've got a few different cases over here, and there will be a couple errors to deal with as well. Okay. And again, that's the end of this stage, and so you've got some details on order testing, style checking, and submitting. All right, stage 3. So I'll go through the structure of stage 3 quickly, but I'll only go through the commands very briefly. So stage 3 adds the concept of attempts. So we've got climbing routes so far, but now we're actually going to log when someone attempts a climbing route. So when someone attempts a climbing route, there's a few details that we can note down. So first of all, we have a struct attempt. Yeah, cool. So we have a struct attempt that has a climber name, an attempt type, a rating, and then because this is actually going to be attached to a climbing route as a linked list of attempts, you're going to have a next pointer. So I'll show you what that looks like real quick. So after we've got our one-dimensional linked list of struct routes, we're now going to add another dimension to that by having each struct route have a pointer to a list of struct attempts. So this would show, for example, over here, that Jake has attempted the route eternity, and he was successful, and he gave it a rating of 3 stars because he enjoyed it very much. And I'll quickly go through these kind of struct details. So the climber name, self-explanatory, that's the name of the climber who climbed the route. The enum attempt type is the type of attempt that the climber made, which I'll explain in a sec. The rating is just how good they thought the route was, so that's just going to be between 0 stars and 3 stars. And again, the next pointer is going to point at the next struct attempt in the route to make it into a linked list of attempts. All right, and yes, the enum attempt type, this is going to essentially detail what kind of attempts the climber has made. So first go means that the climber successfully climbed the route on their first go. Success means that the climber climbed the route successfully. Fail means that the climber was not able to get to the top of the route or like fell somewhere along the way. And invalid type just means it's not an attempt type. It means that something got scanned in incorrectly. And there will be details on how to handle that error if that shows up. Okay. Any other things here to detail? So stage 3 at the start of this, it details some things that you will want to change in your program to make sure that you can add in the attempts list under each route. All right. So this is going to be the state. This is going to be the structure of the final. This is going to be like the final kind of structure of the assignment. So nothing else is going to add any more structs or anything onto here. So you've got the struct logbook, and that contains a pointer to a list of struct routes. And every struct route is going to have a pointer to a list of struct attempts. So that's going to be the final structure. So there's nothing else to add after that. All right, so stage 3 involves adding attempts. So you pass the climber, the attempts type, the rating, and the route that was climbed. And that's going to add an attempt onto a specific route. Again, helper functions, errors to be checked in order, top to bottom, and some assumptions there. 3.2, you'll be printing the logbook. So this doesn't print just the routes. This prints the route and then each attempt that climbers have made of it. Stage 3.3. Okay, so this is an important one because this is going to be starting off our kind of memory freeing. So stage 3.3 is where you'll be removing a route, but from here onwards as well, when you remove a route and when you end your program, you will need to free all of the memory that is associated with those structs. So here, if you were to remove a route, so for example, eternity from this list, you would remove all of the attempts of it and remove the route itself and make sure the list is still linked up. And then you would also want to free all of the memory associated with the struct attempts and the struct route. And one of the helpful ways to check that is by compiling with DCC leak check. This is going to basically kind of sit in the background, and when your program finishes running, if there was a memory leak, so if you mallocked some memory but didn't free it later, that is going to catch that and show you an error message. And all of the auto tests from stage 3.3 onwards are also going to have a leak check. So if you don't free up all of your memory, then the auto tests will fail even if the outputs for everything are correct. So that's only from 3.3 onwards. This also might mean that you might have to go to some previous parts of your code and change them to make sure that all of the memory gets freed. All right, helper functions and all of that. Say stage 3.4 is deleting a climber's attempts. So instead of deleting a route, you delete all of the attempts by a specific climber. So you're going to have to search through all of the routes and find every attempt by the named climber and remove them. And 3.5. 3.5 is quite a difficult one. You have to take two climber names, and climber 1 is going to essentially copy all the attempts of climber 2, with a couple caveats there, which will be described in the spec, of course. So there's diagrams to help you out here as well. So if you were to duplicate all of Rory's attempts for Tammy, then that would look like this. Okay, stage 4, I won't really go into much at all. One of them is combining routes, and one of them is printing out a leaderboard, which will involve some kind of sorting and all of that. Okay, so let's quickly move on to assessment conditions. So just like in assignment 1, this is an individual assignment, so you cannot work on it with anyone else. So unlike with your labs where you can kind of pair program, this is only an individual assignment. So if you share your work with someone, or if someone copies your work in some way, you could both get in trouble for plagiarism. Importantly as well, GitHub Copilot and other code synthesis tools, such as ChatGPT, those are not permitted. And anything else, I think this is mostly just going through consequences of them. Consequences, they are bad. Don't plagiarize. Yes. All right, and that is, yeah, consequences previously mentioned. All right, so submission of work, this is the same command that has been given throughout the rest of them. So that's just how you submit them there. The assessment scheme, so this is important to remember as well. You're being marked on your style as well as your performance. So 80% of the marks are going to be from the actual performance, so making sure it has the correct outputs, making sure it doesn't have any bugs and any of that. And 20% will be from the actual style, and that's going to be marked by a tutor manually. So for the performance marks, that's kind of, the overview is listed here. So if your stage 1 is completely working and like fully implemented, that's going to give you 35% of the performance marks, so 35% of 80% of the assignment. So if you get that plus like good style marks, that's already given you around 50% or around 40–50% of the assignment. Completely working stage 1 and stage 2 gives you 65% for performance. So that's already getting you up to a credit level there. So stage 1, 2, and 3 then gets you up to 85%. Stage 4 bumps that up to 100% if you get all of those completely working. And that's for performance, of course. The other 20% is still style. Stage 4, as with assignment 1, it can take a very long time and it can be quite tricky. And it's essentially giving you just the last 15%. So it's not something that we expect every student to complete, essentially. Obviously, some students are going to be very keen beans and are going to get on it and are happy spending their weekend on it. Some people will decide that they get to stage 3 and they've gotten a good amount out of it. They've gotten enough kind of experience, practice, learning out of it, and don't feel the need to spend like another full weekend working on stage 4, for example. So again, go through that as you will. We're not expecting every single student to get like 100% for performance. Any tips for stage 4? Yeah, get out a lot of, break out the diagrams, honestly. Like with any linked list kind of tasks, diagrams are going to be very, very helpful. And then stage 4, there's a lot of little like edge cases and things, so you're going to want to check all of those. So you want to check those against the reference implementation because the auto tests for stage 4 are going to be quite limited. That actually goes, as you go through the assignment, stage 1 is going to have quite comprehensive auto tests, but as you go through the later stages are going to have a few more kind of gaps in the auto tests. So you'll want to test them yourself because when we mark them later, we have a more, like a larger range of auto marking tests that are going to check more edge cases than just the auto tests you're given. So, yeah. Anyway, back to stage 4. Drawing diagrams and like really planning it out is going to help, and then testing manually to test for a lot of edge cases is going to be very helpful as well. All right, so style marking, this is where another 20%, the other 20% comes from. I think this is just the exact same as assignment 1, so you should be fairly familiar. Anything else here? Again, more plagiarism consequences. Okay. That should be about it there. Do not use arrays in this assignment. Yes. Maybe I should put that in bold as well. The due date is 17th of November, which is week 10 Friday? Yeah, that looks, I'll trust you on that. Week 10 Friday at 8 p.m. So you've got about 3 weeks to complete this assignment. As with any assignment, start early if you can, because that's going to help you to figure out things earlier on, manage the time, and also debugging is going to take time. You will find your bugs earlier and then have more time to solve them. Okay, anything else, Tammy? Yeah, any questions from anyone in here? All right, perfect. I think we are done. Yes, perfect. Sounds good.